Okay, so here's the homework to Math 110, Section 5.1, Day 1, just in case I'm not in class tomorrow. So the first question, you had to integrate something like a constant dx. And the constant I had was -2. And I'm going to use the constant rule, which says that you're just going to take that -2, multiply on an x, and add capital C. That's the constant rule. So the dx, which is the differential, tells you what variable to use, and that's the variable that you're going to put on the end of your constant. For the second problem, you had something like a constant times t to an exponent. So in that case, you're going to use the simple power rule. And what that says to do is to take your exponent, which was 12, and add 1 to it to make it 13. Take your old coefficient, which was 3, and divide it by that new exponent, which is 13, and add C. So to check your answer, you could take the 13 down and multiply it by 3/13, and you get 3, which makes sense, because when you take the derivative of this, you're supposed to get the original question, and that would give you 3, and then you drop the degree down to 12, and if you took the derivative of your answer, you'd get 3t squared. The derivative of c is 0, so I know that I'm right. In the next problem, I had 9 and y to the -4. So I'm going to do the same thing I did in problem 2. I'm going to add 1 to the exponent, which makes it -3. I'm going to take my old coefficient 9 and divide it by that new exponent, -3. And 9 divided by -3 is -3. And I'll add c. Checking my answer, -3 times -3 is 9. And when I drop the degree down 1, I get -4. On number 4, it's a little tricky because it just says integrate dw. But remember, whenever you have a dw, there's always a 1 in front of it. And so you're really integrating the number 1 with the variable w. So the constant rule says you take the 1 that you had and you multiply it by w, and you add on the constant c. So the answer is w plus capital C. Number 5, we had a e to a power. You may have had a different power, but it's e to some power dx. Could have been d anything. The differential part, this dx, tells me the variable I want to use is x. And this e to the 5th is just a number, like any other number. So I use the constant rule. I take that coefficient and I multiply on x and I add c. So it may have seemed a little tricky because you thought you needed to do something with the exponent on e, but you don't. E to the 5th is a number. Keep it that same number and put an x on the end. Number 6, you had v to some power, and my power happened to be -3/4. So I'm going to use the simple power rule. I'm going to add 1 to the exponent, which turns it into a +1/4. I'm going to divide the old coefficient 1 by my new exponent 1/4, but really if I'm dividing by a 4th, it's multiplying by 4. And I add on c. Checking it, 1/4 of 4 is 1. Drop the degree down, you would have -3/4. The next problem was sort of a fill in the blank. I had the integral of 1 over x to the 8th, and they wanted me to rewrite it. Well, the way that I'm going to rewrite it is with a negative exponent, because I need to use that exponent to integrate. So I need to know it's -8, so that when I integrate and I add 1 to the exponent, I turn it into -7. And then I divide by the old coefficient, which was 1, divided by the new exponent is -1/7. And now I want to rewrite it to simplify it. So they're telling me, they gave me the negative, so I don't have to worry about that. They put the 1 over. I just have to say 7x to the 7th, because the 1/7 means the coefficient is in the denominator, and the negative exponent means the x's are in the denominator. Number 8, I'm integrating 5 minus x dx. Well, the way that I'm going to do that is I want to remember my sum rule. That means that I can just integrate 5 and integrate x, and I can do them separately, and then my answer will just be the difference of those two things. So I can basically break the integration over the subtraction. Integrating 5, if the variable is x, means I get 5x. Integrating x means that I need to raise the degree from 1 to 2 and divide by that new degree and add on capital C. So if I check my answer, the derivative of this is 5, the derivative of this is x, and that's what I wanted. Number 9, I'm going to break it across as well. I'm going to integrate x cubed dx, then I'm going to integrate 5x dx, and then I'm going to integrate 5 dx. So when I integrate x cubed, it becomes x to the 4th, and then I divide by 4. When I integrate x, I get x squared, and I divide the 5 by the new exponent of 2. And when I integrate 5, I get 5x plus c. So there's my answer for number 9, and I can check it. You should check it. Then the last page, you had to do another little step, which was rewrite any exponents that are written as a radical as a fractional exponent. So the first piece that I'm going to integrate, I want to think about it as x to the 1/2. That's what the square root is. Then I want to integrate this next piece, and I want to think about what the coefficient is. So the 1/2 is the coefficient. And then the exponent on x, since it's a square root but it's in the denominator, that means it was a negative 1/2. So I'm integrating the first piece, x to the 1/2, and the second piece, 1/2 x to the negative 1/2. But I'm going to do it with the simple power rule, so I'm going to add 1 to the exponent of the first, and then I'm going to take the old coefficient and divide it by the new exponent, and that'll give me 2/3. Then on the second one, I'm going to add 1 to the exponent, so it's a 1/2. Old coefficient divided by new exponent. A 1/2 divided by a 1/2 is 1. And then I'm going to add on c. Same thing with 11. I need to think about it as x to the 3/4. The index of your radical is the denominator, the fraction, and the exponent is the numerator. And then the second part, I'm integrating the number 4 with respect to x. So I'm going to raise the degree and divide by that degree, and I'm going to put an x on the end of 4, and I'm going to add my constant of integration. For number 12, I needed to think about, again, what's the coefficient, and since the 8 is in the denominator, it's 1/8. And since the x is in the denominator, that exponent is negative 4. So it has to be in that form of a coefficient times x to a power in order to use that simple power rule, just like it did with taking the derivative. But now I'm going to raise the degree 1, and I'm going to take the 1/8 and divide it by that negative 3, so it becomes negative 1/24 plus c. But remember to put your negative exponents back in the denominator. So negative 1/24x cubed. Final problem, you cannot integrate a fraction, so you need to rewrite it as t to the 6th over t to the 6th. And then you're going to rewrite the other one as 7 over t to the 6th. And you're going to get the integral of 1 dt plus the integral of 7t to the negative 3 dt. Once it's rewritten, when you integrate 1, you get t, since the variable is t. And when you integrate 7t to the negative 3, you get t to the negative 2. And then you take your old coefficient divided by your new exponent, add on your c, and then you're going to write it as t plus or minus, I could say minus, that might be better, 7 over 2t squared plus c. So you're just taking that negative exponent to the bottom. And that's the end of the homework.